In this video, we're going to investigate the intersection between a line and a plane. And I got such great feedback from my other videos about demonstrating this with pencils and paper that I thought I'd give it another try here. But I will demonstrate these on GeoGebra as well. So what are the three possibilities when you're investigating the intersection of a line and a plane? Well, the first one is if the line is not parallel to the plane, the line is going to come down and intersect at a single point. So it'll come through and pierce this paper right there and then come out the other side. And so the intersection is a point. That's our first possibility. The second possibility is this, that the line is still, or the plane is still lying here, but the line is hovering above the plane. It would be parallel to the plane. So you can see that it is kind of parallel, but it doesn't touch the plane. Okay, so we say that this is distinct. So when it's parallel and distinct, it's never going to intersect. Remember, this is going to go off and never touch, and then here's our plane going off forever. If the line is not parallel to the plane and it has some sort of tilt, eventually it should touch. But here we've got the situation where the line is parallel to the plane and it's distinct, so there's no intersection. The third possibility then is we still have a parallel line to the plane, but this time it's right on the plane. So it exists right on the plane right there. So it is parallel to the plane, but it's actually a part of the plane. And in this case, then, there is an infinite amount of intersections. You can see all of the possible intersections right along here because every part of the pencil is touching the piece of paper. And if I change the plane, that you notice that you see that the plane is changing as well because it's parallel. So your three options or three possibilities when investigating the intersection of a line and a plane is that it could intersect at a point, it could never intersect, or there is infinite amount of intersections. And now I'll ask Mr. Lee to demonstrate those three possibilities on GeoGebra.
Thanks, Mr. Lee. What we're going to do now is demonstrate that idea of all the possible intersections by looking at a couple of examples on GeoGebra. Incidentally, the three examples I'm going to show you here visually are the same three examples that you're going to do algebraically in a moment in the next videos. So if you wanted to come back and refer back to this video to visually see the algebra that you did, then you're welcome to do that. But this is a great way to demonstrate the three things that I was trying to demonstrate with the pencil and the paper. So in the first example here, I've got a plane that is just outlined like there, 2x minus y plus 4z equals 9, and you can see that plane, okay? And it just sort of exists off in the space. And then I've got the line, which is represented here. And hopefully you can then see the line actually intersecting with the plane at a specific point. So if I hold it like here, you can see the line coming through and piercing the plane at that point, and this dotted line is what you can't see behind the plane, and then it comes out there. So if I move it around, you can actually see it piercing through the plane a little bit even better there. And GeoGebra actually allows us to do the calculation to find the intersection, and it finds that the intersection is a point, the point 551. And like I said, you're going to do example 1 and find out that that is the answer to that example. So it comes through. So this is our first scenario or possibility when you're investigating the intersection of a line and a plane, is that that line could come and intersect the plane at a single point. Next, a second example, I've got a different plane here, although it'll look kind of the same, but it is a different plane, a different equation, and I've got a different line. Okay, and at first glance, it looks like that line is sort of traveling along the plane, okay, which might be the case, but if I twist this a little bit, you will actually see that the line, there it is, you can see the line is hovering above the plane, okay, just ever so slightly hovering above the plane. And so the line itself is parallel to the plane. There you go. It's parallel to the plane, but never touching the plane. Okay, so that is one of the possibilities. So if you look at it from above, it might look like it's lying on the plane, but it's actually just above it. Okay, so that's the second possibility. And therefore, if the line is parallel to the plane, then there's going to be no intersection, no possible intersection. parallel and distinct, I should say. Parallel and distinct, so it's separate from the plane. Okay, and our third example is, again, a different equation and a different line. And here's the plane for that line, and here is, or sorry, the plane for that equation, and here is the line. Okay, and this one you can see that it looks like, again, that the line is laying on top of it, but I'm just going to twist and make sure that it's not parallel. No, you can see that it's lying right on the plane. Okay, so that is our third possibility, that the line is parallel to the plane but is not distinct. It's the same line. And therefore, if we're talking about the intersection, we're saying there's an infinite amount of intersections. Okay, not just all these, but because this purple plane goes off forever and so does the line, there's an infinite amount of intersections. I've asked GeoGebra for the intersection of these two, and it has a question mark because it can't handle the fact that there's an infinite amount. And even in the second example here, I've asked for the intersection, and there is none. So again, it doesn't know what to do because it can't intersect. The only one it can show me is this first example where it intersects at a plane. So your three possibilities are, when you're investigating the intersection of a line and a plane, is they're going to intersect at a single point, or they will be parallel and distinct and have no intersection, or they are parallel and the same and the line lies on the plane, in which case there is infinite intersections. So you can go off and do examples or watch the next videos. And like I said, if you want to come back, you will see each of these actual numbers show up in the three examples that you'll see in a moment. Good luck with that algebra.